Today we are going to talk about inscribed angles. That's a new term for us, so we will begin by defining it. An inscribed angle says is an angle whose vertex is on the circle and whose sides are chords of the circle. So to draw an inscribed angle, then, we need our circle. The vertex is going to be on the circle, and the sides are going to be chords from that vertex. Theorem 9.7 tells us about the size of an inscribed angle, but you actually discovered this theorem on your own a couple nights ago. Not in last night's homework, but in the night before that, you had a picture that looked like this. And in those problems, we were given how big the arc was. Let's say that arc is 40. And we were asked to find how big this inside angle in here was. What kind of angle is that? What do we call that? A central angle. And how big was that central angle? 40, the same size as the arc. And then you were asked to find this little angle over on the edge, which today we are defining as being an inscribed angle because its vertex is on the circle. And what was the rule that you came up with for how we could find that inside angle?
The line has to be 180 and get minus 40 and get 140. Then the other two angles have to be the same, so you divide it by 2 and you get 70.
So the process was correct, that we could think about what's next to that 40 as being 140, and then we have an isosceles triangle, we could get our way back. But in our homework problem we had a chart, and by the end of that chart we found a pattern that we could just jump directly to that angle. Does anybody remember what that pattern was? 180 subtract 40 would give us the angle that's right next to the 40, but not that one that's over the corner. What was the pattern for that angle? It's the very last column of our chart.
It's the same as the angle that the central angle.
It is not the same as the central angle.
No. Just before, yeah, they have the same arc, don't they? So they would have 40.
They do have the same arc, but one is a central and one is inscribed. It is half. Our rule in that last column was x and 2x from that chart, which is what we would get if we thought about that process of subtracting out and saying this is 140. So that would leave 40 left over for those other two angles that would be split equally, and they would both be 20 then. So our rule is that an inscribed angle is half of the arc that is cut off, which is what Theorem 9.7 says. Theorem 9.7 says that an inscribed angle will be half of the arc that it cuts off. A central angle will be congruent to the arc it cuts off. An inscribed angle will be half of the arc that's cut off. So we have some corollaries to this. The first corollary has a grammatical error. Drives me crazy. If 2, that's the wrong 2, should be 2, the number 2, TWO. If 2 inscribed angles intercept the same arc, then the angles are congruent. So here is one inscribed angle, and it is cutting off this arc over here. If I draw another inscribed angle that would cut off that same arc, those two angles are the same size. Because since they're cutting off the same arc, they would both be half of whatever that arc is. So if 2 inscribed angles are intercepting or cutting off the same arc, they will be congruent. Our second corollary says an angle inscribed in a semicircle. Remind me of what a semicircle is. Half a circle. So if I wanted to make a semicircle, what do I need to draw into my picture? The diameter. So there's my diameter. Diameter is a chord that goes through the center. It says an angle inscribed in the semicircle is a right angle. So if I put the ends of my angle on that diameter, well, how big is a semicircle? 180. And if an inscribed angle is supposed to be half of that, that inscribed angle then must be 90. And this would be true no matter where I put the vertex of the angle on the circle, as long as the endpoints are on that diameter. So we can get some kind of cool pictures. The third corollary says if a quadrilateral, what is a quadrilateral? Shape with four sides is inscribed in a circle. We looked at inscribing shapes in circles in our first lesson. When I put a shape inside of the circle, what do I need to make sure happens?
All the angles hit
So I can get my 4 points, stack them up. That gives me a quadrilateral inside of that circle. It says then its opposite angles, so I'll say like X and Y, are supplementary. What does supplementary mean? Add up to 180. So according to that corollary, X plus Y would equal 180. And we have one more theorem. If I have, lost my connection. If I have an angle that is formed by a chord and a tangent, so here's an angle that I made by a chord to the circle and a tangent to the circle. It says that angle is equal to half of the size of the arc. So however big the arc is, that's cut off right there, that angle is half of that. So both of our theorems today, we only had two theorems, and then we had a few corollaries to go along with them. But in both of our theorems today, we're talking about halves. So an inscribed angle is half of the arc that's cut off, and an angle that's formed by a chord and a tangent is half of the arc that's cut off. The arc from the end of the chord to the other end of the chord.
How do you find that?
You would have to be given that. So if we were given that that was 80, then we would know this angle is 40. But you'd have to be given one piece of it. All right, so let's do some examples. I have 6 problems here. I want you to take a few minutes to try these problems, and then we will discuss them together. In the first one, top left, what do you think about X or Y?
38.
Why will they both be 38? All of those angles intercept that same arc. So that first corollary said if two angles or more angles intercept the same arc, then they will all be the same size. So that 38-degree angle is cutting off the arc that I just highlighted along the top there. X is also cutting off that same arc. Y is also cutting off that same arc. So all of those angles must be the same size then. So they are all 38. Top center, what do you think about X or Y?
X equals.
X equals 25. Why does X equal 25?
It's half of 50.
It is inscribed in an arc of 50. So since that arc is 50, X inscribed in that would be half of that, so 25. What about Y?
Well, the other angle is 90.
Why does the other angle have to equal 90?
Because you have a line going through the radii.
We have the diameter drawn in. We have through the diameter is drawn in, which means that we have a what? A diameter, which creates a, when we cut the circle in half, semicircle. And one of our corollaries said if we have an angle that's inscribed in a semicircle, then that angle is a right angle. So we have a right angle there. So if we know that we have a right angle and x is 25, then how can we find y?
It's 65. You subtract, or you add 90 and 25 and subtract that from 180.
Yep. Add up what we have and subtract out from 180 inside of that triangle. A second way of thinking about this question. How big is a semicircle? 180, right? So if we have a 50-degree portion, this other portion must be 130, and that y is inscribed in that 130. Half of 130 is 65. So a second way to getting to this. But for both of those ways, you must recognize that we have a semicircle there because the center is drawn in. If the center is not specifically labeled, do not assume that it is a diameter. For example, in the picture below this one, it looks like that line might be a diameter, but since the center is not specifically labeled, do not assume that it is a diameter. On this one, the point was specifically labeled O, so we knew it was the center. But unless it's specifically labeled, do not assume that it is a diameter. Third picture on the top, what do you think about x or y?
X is 70 and y is 95.
Y is x 70 and y 95.
There's opposite angles. There's quadrilateral, so opposite angles are supplementary.
There, that said opposite angles in a quadrilateral that is inscribed in a supplementary. Supplementary means adds up to 180. So we can take those opposite angles, subtract out from 180 to get what's left over. So that was one of our corollaries again. Bottom left. Sometimes you could solve for either one first. In this one, we need to know x before we can know y. How big is x? X is 120 degrees. 60 is an inscribed angle there, cutting off the arc of x. An inscribed angle is half of the arc, so the arc must be 120. Now, y is an angle that is created by a chord and a tangent. What is our rule for an angle created by a chord and a tangent? Half of the arc it cuts off. If we have an angle created by a chord and a tangent is half of the arc that's cut off, so what will y be? 60, half of that arc of 120. Bottom center, like I said, we don't want to assume that this is a diameter coming in here, so we're not going to assume that we have any right angles in this picture since the center was not specifically labeled. So where could we start this? Half of 150 will give us this angle over here, will be 75. We weren't asked for that, but often in your problems today, you will need to find something that we're not specifically asked for to help us find something we are asked for. So how does that help us find something? Add those up and subtract them from 180 will give us x is equal to what? 65. What about y? Y is created by a chord and a tangent. So our rule said an angle created by a chord and a tangent will be half of the arc that's cut off. So that means I need to know how big this arc is along here. How do I find out how big that arc is?
You can do 360 minus 150. Right? And then divide it by 2.
we do 40 times 2 is 80. The way some of the rest of you were thinking about doing 360 minus the 150 would give us the entire rest of the circle, and it does not necessarily divide up evenly. So we couldn't just divide that up by 2 and say that they would both be the same. They're not necessarily going to be the same unless they are marked as being the same. So the quickest way about it is to take that 40 and double it to get the arc. And then what would y be? 40, half of the arc that's cut off. Okay. An angle created by a chord and a tangent is half of the arc that's cut off. So since that arc is 80, the angle will be 40. Last one. What could we know there?
We know that the opposite angle is 40.
Okay, the angle we were not asked for is 40. It is inscribed with the arc of 80. Inscribed angles are half, so that angle would be 40. How does that help us?
But no, I have to equal each other, like the legs are congruent.
Since we have two congruent sides, we have an isosceles triangle. That means x and y are going to be the same. So how do we figure out how big they are?
We can subtract 40 from 180, that gives us 140. And then we can divide that by 2, and that gives us 70.
So subtract what we have from 180, which leaves 140, divided up equally for those two, leaves 70 for both of those base angles. Okay. Your homework is from section 9.5 tonight, 1 through 9 and 19.